The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
I would say a couple of things, kind of generally speaking, that I think people don't realize about floating solar is I often say, we're the footprint of a rooftop system on the ground is really the best way to look at our systems. So when you think about, and this obviously ranges depending on where you are in the country, but a megawatt of solar on a ground system is typically going to run you, between 5 acres or so, right?
Mm-hmm. Yep.
For us, a megawatt's going to be just under 2 acres. So when you start to actually think that out and expand that out, it's you're saving a significant amount of land by deploying this on water versus on land.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, photovoltaics. My guest today is Stetson Chividjian and Jennifer Quas. Stetson is the managing director at a photovoltaics company called D3Energy based in Florida, and Jennifer is the account manager Southeast for CPS America. Welcome to the show.
Thanks for having us.
Thank you, Tim.
Floating solar is a hot topic, no pun intended. It is still early days for photovoltaics in the United States, but there have been analyses done that there are enough bodies of water that you could solarize, that we could produce some big percentage. I don't know what that is. Maybe you know that statistic off the top of your head, Stetson, but it's some tens of percent of our energy could be produced with photovoltaics. So it's something that you solar professionals should definitely pay attention to and learn more about, and hopefully this episode will help you on that journey. So Stetson, tell us a little bit about D3Energy and how the company got into photovoltaics.
Yeah, so D3 is unique in the fact that since its inception, we have been floating solar only. So this is going back into 2014, 2015. We're based out of South Florida. And if you're familiar with South Florida, you know that there's a lot of bodies of water, retention ponds and stormwater ponds and things of that nature kind of throughout the area. And so really this idea was born of going, hey, what could you do with all of this extra space that we have, right? You have to have the stormwater. And so just really fell in love with this like kind of great answer to being able to utilize those spaces for solar. And so we have kind of been a floating solar developer from day one. I jokingly say this now, but back then there was a lot of weird faces we would get, and question marks going, "What are you talking about? Putting solar panels on water? Are you crazy?" And so it's been really satisfying and neat to see the adoption of this technology in the U.S. here over the last 10 years. And it's really been satisfying for the D3 team to kind of be at the forefront of that. We can proudly say we've built the most floating solar systems in the United States, really all over the country at this point, all sorts of different types of climates, different types of bodies of water. But we've purposely kind of been painted ourselves to really be experts in a very narrow field here of floating solar. So for everything from the design, and the engineering through construction and even operations of our systems is really where we excel.
Very cool. That's a great story. And I never would have guessed that a solar developer would specialize in photovoltaics, but that's cool. And Jennifer, tell us a little bit about yourself and how you came to be working with D3.
Yes, thank you, Tim. I've been with CPS America since September of 2022. I left the healthcare industry and chose solar. That was something I was very fascinated about. And prior to healthcare, I used to be involved with U.S. Green Building Council from 2012 to 2014. So I always joke around, part of my DNA is all about sustainability and recycling, repurposing, and then water conservation. I was an organic gardener for years personally. So I'm just very passionate about the sustainability aspect of it. And I started listening and learning more about solar applications. And Stetson's D3 Energy came up through U.S. Green Building Council, and I just thought it was fascinating. Floating solar, like that to me was just a no-brainer. Why would we not do it, right? And now I've gotten to learn more about it. And Brian Baxter was originally Stetson's account manager, but I was like, no, let me do it. I want to do it because I was really wanting to just support him and what he's trying to do, and again, just be part of that network that he's growing and developing with floating solar.
Very good, very good. And shout out to Chris Bartle at Seal and Tear. Seal and Tear is really the dominant floating racking company here in the United States. Chris Bartle has been on the show. Would like to get Chris back on the show to talk more about the big picture. But Stetson, set the table a little bit for us. What is going on with photovoltaics? We're going to talk about a project in Ohio. It is happening in many markets, not all markets, but many markets. Some people who listen to the show would have heard about projects in New Jersey, of course, California. And Jennifer touched on some of the benefits in terms of reducing evaporation, for example, if that's a goal. Some drinking water facilities can be covered with photovoltaics. But Stetson, set the table. What's the scale of the industry and where are the hot markets?
Yeah, great question. So let's go really big picture, right? So for those that aren't familiar with floating solar or just kind of, heard headlines, same solar panels, same wires, right? There's nothing very different from the electrical principles of a floating solar system as though a ground or roof. It's just an alternate way to rack it. And when you think about solar in general, one of the biggest kind of hurdles that people have to overcome for getting a project really off the ground is space. And whether you're trying to acquire land or trying to find enough rooftop space, it becomes a big challenge. And that, in my opinion, is one of the most difficult things about solar, is that you need a very large footprint to deploy the type of energy that most of these companies and municipalities are really trying to deploy here in the next couple of years. And so I think floating solar really answers a lot of those questions, because an example we're going to look at here today for this Ohio project, this water utility's got a massive reservoir right next to their water plant that consumes a ton of energy. And so you see certain circumstances like that to where like floating solar is just a perfect fit, to where you would have never had enough land to be able to deploy that kind of solar. You don't have enough rooftop space, but utilizing this body of water now gives you the ability to deploy large scale solar. So I think that's kind of the underlying theme in almost all of our projects, right? Whether it's for an office building, to a theme park, to a car dealership, to a water plant, is the same type of theme of going, hey, we really want to do solar. We don't have the space. Now you introduce floating solar, and you actually are able to, accomplish that goal now.
And as far as you're aware, like how many states have floating solar projects installed in them now?
Yeah, so at this point, I mean, we've pretty much broken into almost every single region. As I said earlier, based out of South Florida, Florida and the Southeast was really kind of our natural spot that we started. The early days, that's where we deployed a bunch of our projects. Obviously Midwest, which is the one we're talking about here today. We just finished one out in Utah. There's projects that have been done in California, the Northeast. So it's been pretty neat to kind of see the adaptability of floating solar, from hurricane force winds in Florida to severe snow loads in Park City, Utah. You're able to see kind of the wide variety of different applications where floating solar really works.
I'll put a link in the show notes. There's a great web page from Idaho National Laboratory about photovoltaics. It says that 30% of U.S. reservoirs could be covered with photovoltaics, and that would produce 1,900 terawatt hours of energy and save 5.5 trillion gallons of water annually. So it's a significant resource that we're talking about here. And I'm glad that you spelled out that this is just solar happens to be floating on a reservoir or a lake or whatever. And of course, the racking then is unique. Let's just kind of go a little deeper into that. Is it typically 5 or 10 degree tilt racking, or what is that tilt?
Yeah, so it will range depending on where we are in the country. We work really closely with Cielitaire, who you mentioned earlier, Chris Bartle. And so they've got some different kind of characteristics to their systems depending on where in the country you are. So, for example, our projects down in Florida, where we're having to design them for category 3, 4, 5 type hurricanes, we'll deploy a lower tilt because that dramatically reduces the wind load. For a project like we're talking about here in Ohio for Delco Water, we're typically at about a 12-degree tilt. So 12-degree tilt's kind of the sweet spot that we've found to where you're still maximizing production. You're not impacting, production too much by going with a lower tilt, but you're still dramatically reducing the wind load as well.
Very cool. And
I would like to point something out.
Go ahead.
Something that's fascinated me is as water rises, it is more resilient. It does, adjust. So flooding is a big thing too with these hurricanes. And so it held up really well, I think, with the last couple of hurricanes. I live in Babcock Ranch, Florida, which used to be cattle farming. So it'd be great to see one of those floating solar arrays around here. But then also the water conservation, we just need to be long-term thinking with how we can use solar but benefit in other ways too. So there's a lot of benefits to sometimes different applications that you don't even realize until later on down the road.
Isn't Babcock Ranch famous for its sustainability initiatives, though?
They are, but I haven't seen floating solar yet. So,
but there is ground mount solar, right?
Oh yeah, 275 megawatt.
Yeah. And it's held up very well so far, right? Those ground mounts have held up under the stresses of several storms, right?
Yeah, 3 hurricanes, Ian, Milton, and Helene, and we haven't lost power or internet.
Yeah.
Yeah, and that's a great point to what Jennifer said. I mean, we have about almost 10 systems in kind of the Central Florida area alone. And so Milton that just ripped through there like a month or so ago now at this point, 0 reported damage on our system. So it was a real world test for us to be able to see how these systems and the flooding and that storm surge and that water level rise is a big part of that. And so we design our systems to be able to withstand those water level variations. And so as the storm surge rises, so does the array. And then when it subsides, it comes right back down. So it's neat to see it be able to, I was out in Utah on a site where it's going to be dealing with, for freezing conditions and snow and all of that. And then to be able to come back home to Florida and be able to see our systems be resilient in a serious hurricane, is pretty neat.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 3-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes 3-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Well, let's talk about Delco Water. This is a project in Ohio. It's a 1.6 megawatt project. Is that right?
That's correct. Yes.
Okay. How did the project come to be, and why did Delco choose to go floating?
Yeah, so this was a project that was in the works for a very long time. As anybody in the solar world knows, that's typically the case when developing these projects from the ground up. We had some local presence there in the Ohio area, MSI Utilities, that had kind of come to us and said, "Hey, we love what you guys are doing with floating solar. We've got a client that we think's really interested in this." And so that's really where the conversation started. Delco Water, to their credit, has always been a very forward-thinking water utility. It's never easy to be first, especially when you're a utility. And they had just loved the idea of being able to kind of trailblaze floating solar in the state of Ohio and really to be, the first ones to do it. And to go back what I was saying earlier, they had a bunch of kind of green initiatives. But if you look at their property, just very limited in the amount of land available and very limited in the rooftop space available. And so when floating solar was brought to them as a solution, it to them was, an answer to their problems. And so it's a pretty neat project because it's the first time that we've actually blended floating solar with rooftop solar and with carport. So it's kind of like a really neat testament to just solar in general and all the different types of mechanisms that you can kind of utilize to deploy the green energy. And so, went through the early processes with them of just the feasibility, had to go through the utility studies and everything like that. Even the Ohio Department of Natural Resources has gotten involved because the reservoir itself is actually considered a dam. So there was a bunch of different kind of red tape that we had to make sure was checked to get the project approved there. And then once we received all those approvals, it was pretty smooth sailing at that point. And we're able to deploy the project. It offsets a majority of their power at peak production, so it's able to reduce their energy bill significantly, and be able to rely more on green energy versus the utility.
And Jennifer, at what point did CPS get involved with the project?
Well, I've been talking with Stetson for a couple years now, and I think the big turnaround was when I invited him to the booth at one of the trade shows, and I just said, let's look at all the different inverters we have to offer. And, the big takeaway with CPS is we have 2 wire boxes, and we can offer that with most of our product line. And so for the 100 kW, we have the centralized wire box, and then we have the distributed wire box, which is more like standard wire box. And so he tends to use the central wire box for the floating solar array, but then when it came to the carport and rooftop, which is kind of different for them, we had the rapid shutdown wire box for the rooftop, and then we had the standard wire box for the carport. So I think we just have lots of different products with flexibility in making the system perform at its most capacity, but also giving it versatility.
So the Delco project has a floating component, but then a rooftop and a carport component. And does that mean there's another developer involved, or was D3 also doing those components?
No, D3 wrapped the entire project and completed all of it. Yeah. And to Jennifer's point, I mean, that was a huge part of working with CPS on this project was, the wide array of products that they offer, and because of the uniqueness of each array kind of having its own set of characteristics that it needed, it was really helpful to work with them, and not only on a product side, but also from like an engineering side. I mean, their technical team was very helpful in trying to help identify the best product for each array and what would work and everything like that. So it was great to have their support along the way.
I mean, when I look, and I'll put a link to the show notes. You have some nice aerial photographs of the Delco project on your website. When I look at that, though, I immediately think, okay, and as you guys have referred to, the water body can go up and down over time, and so and it's no big deal for the floating array on the top of that, but the anchoring system strikes me as being a little complicated. And then, of course, you're running a big power cable back to shore. So tell us a little bit about that. And then how do the inverters integrate into a floating array? Are they on shore or on the array themselves?
Yeah, great question. So The anchoring system is typically one of the more complicated parts of a floating solar system in general. I would say for this project, even more so the case. So I referenced it earlier that the ODNR got involved, the Department of Natural Resources. This reservoir in particular had what they call a liner, right? So we weren't able to do any type of earth anchors or driving any type of anchors into the ground because we would have punctured the liner of the reservoir. So we had to get very creative in the type of anchoring system that we could utilize. Even the means that we installed it, we had to be very, very careful that we didn't have any kind of spuds of our barges that would penetrate that liner. And then in the actual design of the system, what we do is, the best analogy I can use is think of a mooring system for a boat, right? Think of high tide and low tide, and so you'll have enough slack in those mooring lines to be able to kind of withstand whatever that varying water level is. And so we worked very closely with Delco Water, who obviously manages the water levels, and said, okay, worst case scenario, what would the lowest water level ever be here possibly? And then and then same thing for highest water level, what would that ever be? And then we designed that anchoring system around that. For the conduit connecting both array to shore, same thing. So you'll see that when the water level's higher, that conduit kind of actually does more of like a snaking motion. So it has enough slack into it. But if that water level were to ever drop significantly low, you'll see that conduit kind of expand and straighten. So all of that kind of goes into the design of floating solar and is, part of the unique nature of FPV in general. In terms of an electrical standpoint, really the only thing that's out on the array are your solar panels and then your DC combiner boxes like Jennifer referenced earlier. And so then we're running all those DC feeders back to shore, and then your inverters were on shore for this project. So at that point, once we're landing the inverters on shore, from the backside of the inverters to interconnection would be, pretty standard, interconnection in landside system.
Right. Wow. Well, I don't really have any other questions about the Delco project, but what else should our listeners know? Jennifer or Stetson, what else should our listeners know about developing floating solar projects and some of the technical challenges that both companies had to overcome to see this to fruition?
I would say a couple of things, kind of generally speaking, that I think people don't realize about floating solar is I often say, we're the footprint of a rooftop system on the ground is really the best way to look at our systems. So when you think about, and this obviously ranges depending on where you are in the country, but a megawatt of solar on a ground system is typically going to run you, between 5 acres or so, right?
Mm-hmm. Yep.
For us, a megawatt's going to be just under 2 acres. So when you start to actually think that out and expand that out, it's you're saving a significant amount of land by deploying this on water versus on land. And so I think that's something that other developers, other contractors or utilities that are looking at it's one of the first things that jump out to them to go, wow, this is a huge advantage. Instead of having to procure 6, 7, 8 acres of land for this system, we were able to deploy it on essentially 3 acres of water.
I was always curious to know, especially in like Florida or South Carolina, how do the alligators, how do the other natural creatures, how did they deal with the floating solar? I was always curious about that side of it.
Yeah, so we did a project for D3Energy out at one of their power plants in Central Florida, and I think they estimated there was about 1,000 alligators in that cooling pond at any given time. So literally a alligator infested body of water. But we've never had any issues with it. Sometimes we'll see little baby gators that'll crawl up and sunbathe on our float around the perimeter, but never any issues in terms of equipment being damaged or anything like that. One of the really neat things about Cielo-Terra's system, when you look at it, if you look at the aerials, it looks like a solid kind of tabletop, but it's actually not. If you were to take the panels off, it almost looks more like a checkerboard. And that was actually very purposely done by Cielo-Terra because you never want to create a scenario to where some type of mammal or a waterfowl were to go under the array and then be trapped and potentially harm the animal. So wildlife is something that's always been front of mind when we're deploying our projects. And so it really integrates well with kind of the environment. And if anything, we've seen kind of positive impacts. Tim, you mentioned it earlier, things like reducing evaporation, reducing, unwanted algae blooms or vegetation growth. Those are some of the things that we've actually started to see clients come to us and go, hey, the solar's great. Yeah, we want to deploy solar, but we're actually really interested in, this, whether it's evaporation or something like that. There's the famous story I like to reference in LA. I think it was about 10 years ago. They deployed like 30 million of those little black plastic balls during one of their droughts to try to save some of their drinking water. And so floating solar is essentially the exact same science. It's HDPE plastic floats on the water, but instead of just having the plastic there to reduce the evaporation, on top of that, you're deploying green energy as well. So you're kind of seeing that same application, but with a solution on top of it.
I love it. That's another testimony to just how creative solar innovation can be. Yeah. I mean, agrivoltaics isn't, with the animals, the sheep or the cattle, it's bee pollen. It's, I think we're just at the forefront of like all the creativity that can be possible.
Yeah. No,
I'm curious,
absolutely.
Stetson, does a floating solar array require any special O&M that a ground mount or rooftop solar does not?
Yeah, definitely. So, I mean, there's O&M side. So there's kind of pros and cons to O&M on floating, right? You think about a ground system, you eliminate all of your typical kind of land management costs, mowing the lawn, fencing, security, vegetation control, like all of that essentially goes to zero with floating solar. But then you add, different types of things for floating solar, like the anchoring system, and wire management's a really big thing for our systems because you're over water. So there are definitely some unique characteristics to O&M, but from a cost standpoint, I'd say it's very, very comparable to what we see for a ground system. So there's not any kind of cost adder, I guess, between a floating system versus a ground system.
Great. Well, I want to thank Stetson Shavidian and Jennifer Quast for coming on the show today to geek out on floating solar. And please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify. And please reach out to me on LinkedIn. I love hearing from my listeners. Stetson, how can our listeners find you?
So D3Energy.com is our website. Feel free to there. And Tim, to your point, as floating solar has grown for us, so has the interest from other developers and other EPC contractors and such. And so it's been really neat to kind of collaborate with others. We love that idea of kind of collaborating and being able to bring these projects to fruition. So feel free to reach out. I'm on LinkedIn as well. So happy to always kind of talk to other developers on potential projects.
Awesome. And Jennifer, how can our listeners find you?
Well, I'm also on LinkedIn, and then, jennifer.quaz@chinpower.com. That's my email.
Excellent. I'm Tim Montague. Let's grow floating solar. Thanks, everybody.
Thank you.
Thank you.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chinpowersystems.com to find out more.